Hello, here we are, Cvetomir and Daniel. We are members of the SciNoj group, and we will share with you a little update about the upcoming conference, the SciNoj Light conference, a data analysis conference in the Clojure language. And both Cvetomir and myself, we are speakers in the conference, and today we will focus on a little intro to Cvetomir's talk, and in a moment we'll ask Cvetomir to say something about it. Um, yeah, or maybe uh, just for now, Cvetomir is showing us the website of the conference, which is maybe familiar to most of you already, and then we can just go through the schedule for a moment just so that we can see uh, when and where things are happening. And so you see, it is a 2 days conference, which is full of data analysis talks and background talks about certain topics of math and statistics and the relevant tools and libraries in Clojure. And on Saturday, the second day of the conference, we will have Svetomir's talk towards the kind of the middle of the day in UTC time zone. Yeah. Hello, Svetomir. Would you like to say something about yourself, about who you are, and also about your talk?
Yes, of course. So my name is Cvetomir Dimov. I'm a researcher in cognitive psychology. Over the last few years, I've been studying collaboration, and here I'm presenting a small research project with a new collaborative video game that we have been developing. And here I'm specifically presenting the first stage of the development of this video game, namely testing it as appropriate to study planning. Eventually, we're going to use it to study collaborative planning.
Yeah. Is it okay to ask, briefly a little more about yourself, about your research group, and so on?
Yes, of course. Um, so I used to study collaborative skill acquisition um, a few years back, and now I'm uh, extending this yeah, this research topic with collaborative planning specifically. Um, I'm a cognitive psychologist. I have a relatively small research group. It is just me and one research assistant. And my goal is both to study this topic empirically and also to construct cognitive models that learn to collaborate in a way similar to humans.
Yeah, fantastic. Yeah, so maybe if it makes sense, we can just look a little bit into the topic of your talk and just give a little taste of what it is gonna be.
Yes, of course, maybe I should first start with presenting the video game.
Oh yeah.
Um, so this is the video game. It's called Tick Tick. So now I'm going to demonstrate how the game works and one level, how to solve one level in this game. So the idea behind the game is quite simple. There is a fireball that wants to go to its final target location, in which case it's a fire circle at the bottom of the screen. And there's also an ice cube, which wants to go to its final ice location, which is in this case an ice square on the top of the screen. The problem is, however, that the ice cube cannot cross fire barriers. So if it touches a fire barrier, it dies. So to cross fire barriers, it needs help from the fireball. So the fireball needs to block these fire barriers like this and let the ice cube go through. In this case, we can start the level by blocking this ice barrier, after which the fireball can block the fire barrier so that we can go past it. Then it can block the other fire barrier. And finally, the ice cube should block this ice barrier so that the fireball can go to its target destination. As you can see on the top of the screen, we are presenting the blocking count, so how many blockages we use throughout the level. 4 in green represents the minimum number of blockages possible to solve the level. 13 is the blockage limit that we give, and 6 is the current number of blockages used. We push people towards planning more by, first of all, providing them a bonus if they manage to solve a level with the minimum number of blockages, and secondly, by decreasing their blockage limit. The fewer blockages they have, the more likely they will plan.
That is so nice. Isn't it so nice? I mean, the aesthetics and the whole idea, which is so simple but complicated at the same time, isn't it?
Yeah, it's a very minimalist game in a certain way. There's not too much going on. We only have barriers and cubes, but it allows us to vary uh, the level difficulty gradually from very easy to very difficult. We can very easily create levels that are impossible for most novices to solve within a reasonable amount of time.
Yeah. Yeah. Would you like to tell a bit about your research and what you did and what you're gonna share at the talk?
Yes. So first, I'd like to mention how we create levels. Um, to speed up the process of creating levels, I wrote this little level creator and solver. Um, it allows us to add barriers. For example, here we added 2 ice barriers and a fire barrier. And then we look for the solution to this level. And the solver uh, separates the playing field into regions and finds the solution to a level, including the optimal solution. This saves us some manual work, and it speeds up the entire process a lot. So using this solver, um, using this solver, um, I created a whole set of levels that vary from very easy to very difficult. And the goal of these levels is really to allow us to precisely measure how good people are at planning. Um, once we have found a set of levels that allow us to measure people's planning abilities, then um, then we can move on to the next part of the research project. And this is what the talk is going to be about. About a few set of studies that allow us to find the exact set of levels that will allow us to measure planning.
Yeah. Fantastic. Would you like to share anything more about the talk, or maybe leave it open for curiosity for the people coming to the conference?
Um, I can also mention briefly um, hmm, what uh, what we mean by solving a level.
Oh yeah.
Mm, okay. So this is one of the plots from my talk, and what we measure here, individual points represent individual levels. And what we're measuring is what is the probability that a subject in my study solves that level optimally. And what we have found is that several characteristics of the level predict the extent to which people will be able uh, to solve these levels optimally. And I will go a little bit more in detail about what these characteristics are and also how successful we are at predicting level difficulty based on these characteristics.
Yeah. Yeah, so it looks like certain properties of the levels may say something about how difficult they are, difficult or easy. Right, yeah. And is this based on actual, plays by many human beings?
Yes, exactly. It is based on empirical data.
Yeah, 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 wonderful. So I'm glad we could see a little bit of what is coming in your talk, and I really appreciate it that you could share it with us now. And do you wish to say anything more about your talk before we say goodbye to our listeners for this video?
Well, I'll leave it. Uh, I'll leave the rest of the details for the actual conference.
Yeah, that's great. Yeah. So thank you so much, Cvetomir, and thank you for the people listening to us. We are looking forward to see you all in the conference, May 16 and 17, and the preparation workshop 1 week earlier. So goodbye for now, and see you on the next times.
Bye bye.
Bye bye.